Hey, Matt.
Hey, Mike.
Should we do a podcast in your office together?
We should, although that's kind of weird.
Welcome to Hacking the Grepson. Hi, it's Mike here with Matt, and it's been a while, but we're actually doing this episode in person in Matt's office.
Yeah. So if the audio is weird, that's why.
Different.
Different. Yes. Unusual.
Flavorly...
Bespoke.
Flavorly bespoke, yes.
What are we talking about today, Mike?
Let's talk about compilers versus interpreters.
Okay, so an interpreter is like someone who knows two different languages, and so like if you speak to me in Spanish and then I interpret it in English, right?
Right, and a compiler is like someone who takes like a bunch of things and like smushes them into like the smallest like square.
They just pull them all together, and so like, okay, I've compiled all of these coffee beans over here.
Yes, they were in a huge spread, and now they're in a...
Cool. That was a short episode, Mike.
Okay, well, I'm glad that we made that... No, actually, in software development and computer engineering, etc., they have different meanings. Like, in the briefest way possible, without using the aid of AI, from your own brain, off the top of the dome, how would you describe a compiler?
A compiler takes your source code and converts it into machine code, basically.
Bytecode.
Bytecode.
Yeah.
That gets into some weird discussions there as well. But yeah, something that the machine can understand. Basically, it puts it into a easier to understand by the machine format, a binary. In general.
Okay, now when you say binary is like zeros and ones, right? So it doesn't necessarily go to zeros and ones.
Well, okay, when I said binary, what I really meant is like an executable. It's something, but yeah, it is turned into a language that is less of a human readable thing and more of a computer readable thing.
Right, like a higher level to a lower level.
So, and it does it once, right? Like, so you have all your source code, you've written it, you say compile, and it goes through all the things and moves them into the right formats, containers, how do you want to call it?
Yeah,
it actually might be easier if we take a step back and actually talk about a third thing, which is assemblers. So an assembler takes assembly code, which is about as close as you can get to like manipulating the actual like registers and memory in your computer, and say you move this over there and you don't have all the nice syntax of something like C even. And so when you run an assembler on your assembly code, that turns that into binary, right? So that it says, okay, this is now in the language that my machine understands. So you wrote it in like MOV space R1 space R2, and that says, okay, move register 1 content to register 2. That's the like language you use there, and you assemble it, and it turns it into that exact same meaning, or that exact same idea, but over in machine code as opposed to assembly. Compilers do that at a higher level, right? Because you're not even going to the form of like, take this register and move it over there. You're saying, here's my code. I want you to print something. And then behind the scenes, the compiler knows when you say print, that means you're printing this string. Take these things and put them in this register in this way. Like it effectively writes the assembly. Although I think it just skips that step and goes straight to the bytecode. But it does a lot, but your language is a lot more than like in assembly.
Right. Well, and when you say assembler, because you could write in assembly. Yep. Like, so if you write in assembly and you compile your assembly, you don't compile assembly?
You assemble it.
You assemble your assembly code.
Yeah, but it's basically a compiler. But the difference is...
What is the difference?
The difference is when I write int x equals 10.
Yeah.
That is me using a variable name, and I'm telling the compiler that this variable x is going to be an integer.
Right.
It knows behind the scenes that, okay, that's a 32-bit value that functions in this way. It's don't remember from 25 years ago the various ways that you create represent binary numbers. But like if the first digit is a 1, it's negative. Choose complement. There you go. That's what those things are called. So it knows like the format of those things in your compiler, and it's abstracting away for you when you're using a programming language. It abstracts away from you all that assembly stuff, where the assembly is literally just take these 8 bytes from here, put those over here.
Right.
Right. So when you say int x gets 10, it's like, okay, the value 10, which is 1010, goes into this place in memory, and then I have this other place in memory that I'm going to call x, but the assembler wouldn't know that. And so it's this other registry, and I'm going to say that 10 now gets those values gets copied over into this thing. It's very precise. Compiler, you don't have to do that, thank goodness. But when you run it on your code, it spits out this machine code, and you're done with it, basically. And then at that point, you have a thing that should be usable for the architecture that you built it against, which is usually the computer you're running it on.
Right.
But not always.
Right. So like on Windows, you most likely get like an exe.
Yeah.
And that's something you can double click and then it runs the program.
There are also like sub pieces of that, like libraries and whatnot.
Linkers.
Right.
Yeah.
So a linker would, so you might compile a library.
Right.
And then compile another library and then have a main function that uses both of those libraries, and you compile that, brings in both those libraries using a linker, and then there's a whole thing of dynamic that we don't need to go into right now. Because I don't.
You don't want to go into DLL.
I really don't want to revisit.
double hockey sticks.
I really don't want to revisit that time in my life.
Because believe me, I was about to go there. I only want to mention that like I remember many times running programs on Windows back in the days, like Windows 95, and it like complaining that a blah 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 .dll could not be found.
Yep.
This as opposed to
dynamically linked library, if I remember correctly.
Yes, as opposed to the program you're running having that code with it. Yeah. That was compiled with it so that it doesn't need to look for it when you run it. A lot of programs use, much like in the current ecosystem that I'm more familiar with, web dev and like the Node ecosystem, my simple app that prints hello world to a web page has like 1,000 dependencies because it's being run in React or Angular. Yep. That's kind of now's DLLs. Like it's using code that's shared and should be available to my app, much like everybody else's.
So
app.
I think it's more like that's a shared library. Right? Yeah. It's there. Well, but now we're getting into interpreters, right? Because now that is something that's happening basically at runtime. So when you're compiling, that happens at build time, right? Mm-hmm. You take your code, you build it, compile it,
right,
and then the artifact that produces is these binary files, libraries, DLLs, .a files if you're on Unix back in the day, .o files for object files, right? Like produces these things that you hope you never have to actually look at directly. I've been there and it's awful, and try to avoid that. Yeah. Hackers will look at it. Good for them.
Right. So to get back to compiling though, before we move into interpreting, compiling, I think it's fair to say that in the earliest days of programming, making applications on computers, so like if I wanted to write Notepad, for example, like to get a notepad.exe that I can double click on and boom, I get a notepad editor and I can type text in it. Right. Like in the end, no matter where the source files start, like I'm getting that one executable file that I run.
Correct.
I've compiled, somebody has compiled.
Well, your compiler has compiled.
Right. Like obviously Windows has that file, but at some point it started as source code, so any certain number of files, and then that gets compiled into that one executable that I know to double click on.
Right. Unless there's DLLs, and then that does more things.
I would hope that notepad.exe does not rely on DLLs, but maybe it does.
Who knows?
Right. And if they're missing from your system, it will complain when you run because it's looking for them.
And DLL is a Windows problem, but the same problem exists on Linux machines and Macs.
Yeah, DY-lib files.
Dynamic lib.
Mm-hmm. Yep. I've definitely had issues where programs are like, hey, I can't find that library.
Yeah.
When you try to run something because it's expecting it to be there.
Right. Exactly.
Right.
So that's what a compiler does, right?
Yes.
You take all your source code, you run it through this other program called a compiler, and it spits out something that you can use, or that anyone can use on that particular type of architecture. Right.
So if
that Windows machine, that 32-bit Windows machine, as an example,
which means that it will not necessarily run on a Mac or on Linux or on your iOS phone or Android device.
Yeah. So a lot of times, I think that's the first time people even get aware of these kind of things. That like. If they used Windows forever and they're like, I have this game that I bought on Steam. Mm-hmm. It works great on my Windows machine. I bring it over to my Mac and I can't even open it. Why? Well, because they didn't compile it for Mac.
Right.
And then I think the first time I ever ran into this for real was when operating systems went from like 32-bit to 64-bit. That was all of a sudden like some things didn't work because the 64-bit operating system didn't know how to treat the 32-bit.
Right.
In some cases.
Right.
So that's a compiler, right? It does that stuff. Okay. I've actually written compilers.
I was going to ask if you had. I had not. I didn't go through that course in college, but I know a lot of people.
Academically, it actually got me my first job out of college because the guy that was hiring he'd noticed that people that took a compiler construction class tended to be really good developers, and so he emailed the teacher of that class, who also happened to be the person who ran the ACM, the Association for Computing Machinery, the computer club, which I was the president of at the time. So I responded to the email with my resume, and then I sent it out to everybody else at the school.
Nice.
And that's how I got that job.
So yeah, so compilers are, I mean, like if you were starting out as a dev now, would you really necessarily be working with compilers or compiled code?
Depends on the language, right? If you're doing C, C++, which there's still, that's still out there, it's still being used, you are using a compiler, more than likely.
Yeah.
I believe that people have written interpreters for those, but when you ultimately are building your system, it's going to go through a compiler.
Yeah. So let's switch over to interpreters, because I think there's definitely some gray area between these two, but we need to, let's get the difference. So compile, you write the code, you use a compiler, it turns into some kind of machine or bytecode or something that the machine you're on understands so that you can run it.
Yep.
Now, an interpreter, my best guess as to what an interpreter is...
I really thought you were going to say your interpretation of what an interpreter is.
No, that's what you said. Thank you. You
You're
saved
welcome.
me. You interpreted what I meant to say. Is something that basically does some kind of conversion between one language and another, but on the fly rather than through a compilation station. Compilation station. That just sounds good. No, a compilation stage. There you go. That's what
a build
for. Yeah. Like there's no building. Like if I write a web page in JavaScript, for example, and I make a change to my file, I hit save, I refresh the browser. Yeah. I didn't compile that JavaScript. I didn't say compile, index.js and then run another file. The browser is interpreting my JavaScript file as...
And that's the big difference, right? When you compiled, you got this executable that just works.
Yeah.
The only thing that needs to understand it is the operating system. It's not... Right. You're writing it for a given... You're compiling it for a given operating system and architecture, so that thing knows how to run it, right? If you don't have that compiler installed on your machine, you can still run the thing.
Yeah.
With an interpreter, you have to have an interpreter, right?
Yes.
One of the reasons JavaScript is as ubiquitous as it is, like you said, our browsers have an interpreter built in. Mm-hmm. When I write Python code, like if I write a Python game in Pygame, if I want you to play it,
I need to have Python.
You either have to have Python and the libraries associated with it, or I have to effectively compile that Python. Or you can bundle a small version of the interpreter along with it. Mm-hmm. So it's more complicated for delivering code. Now you get into weird areas with the JVM, which is the Java Virtual Machine, and it's kind of an interpreter itself. Interpreting between the bytecode that Java or any of the JVM languages produces. That is basically its own language that it's writing to. The JVM is the interpreter. So you have I can't remember the names of the program. I think it's Java C is the actual compiler that compiles it into that bytecode.
Yes.
And then the JVM is effectively an interpreter that takes that and makes it so the operating system can run it.
Well, and that was a huge... That was the reason why Java was going to be the most popular programming language that came out. Because it was what was it? Write once, run anywhere.
Yeah, because you had a JVM.
Yeah.
And basically, as soon as you installed any Java program ever, you ended up with a JVM on your machine.
Yeah.
And then anybody else with a Java application could just give you theirs, and I wrote it on my Linux box, and you've got a Windows 95 machine over there.
Yeah, but I can run it because I have that.
Because you have that little interpreter piece.
Interpreting piece, yeah. It can tell, it knows how to take your code that was written on a different machine and run it on my machine because it has that interpretation layer.
Yeah. So I think Java is probably where that type of interpretation, where you have that virtual machine in between, exists. But Java has basically a compiler,
yes,
and an interpreter. So Java has that weird middle ground. But most of the things that we're going to use have one or the other, right? If I'm writing C++ code, it compiles, I get my executable or whatever comes out of it, and I'm done, right? There's not some other interpreter I'm running it through, generally speaking. But if I'm doing Python or Ruby, right, I'm writing that code, it doesn't get compiled. It gets interpreted at runtime.
By the language.
And that's the big thing, right? It's the when it gets turned from this human-readable programming language into something the computer can do something with.
Right.
With compilers, it happens at build time. And with interpreters, it happens at runtime.
Right.
And I much prefer interpreters.
And why is that, Matt? Because I agree, but what's your reasoning?
Ultimately, like, it comes down to the interactive interpreters, right? So when I can drop into effectively a shell, IRB is Ruby's, and Python, I think it's just Python.
PHP-A.
PHP, Perl had its own, right? Where I'm in there and I can just write a line of code and it is immediately able to interpret it and spit out an answer, right? I could just have a calculator that was just Python open. Right. And I wouldn't have to write anything. I could just type 3 times 2 because I know the syntax in Python. Right. And it'd be like 6. Yeah. Right. So you could do all sorts of things. I like that because I have a terrible memory and I cannot remember syntax to save my life. So a lot of times I'll look something up and then I go into my interactive interpreter, which is usually a REPL. I think we've talked about that. Read, eval, print, loop. Which is a phrase I always forget, but you always remember.
So but you remembered it this time.
I looked it up an hour before you came over,
all right,
so I wouldn't forget.
We're making progress, though. Yeah.
And it goes through that, and then you're able to iteratively kind of like write pieces of code and play around with it, and then you can dump it in to your actual file so that so it has some longevity to it. But ultimately, that thing's still going to run through that same kind of interpreter.
Yeah.
The other reason I like that is theoretically, and I've done this, I think, once ever, you could have your code change itself and reload it into an interpreter without having to, like, recompile on the fly. So a code could build something as it's going and then read that.
Right.
So you could have a ever-changing, ongoing, growing type of program.
Yeah. Now, so 2 questions to that. First, what is the reason why there can't be a REPL for C?
There can be.
But there isn't?
I believe people have written some, but it
sounds hacky.
It's more complicated because you have to write your own interpreter then at that point. Right?
Okay.
C comes with the compiler. Actually, there's multiple compilers out there.
Right. GCC is generally the one I use.
That's the open source one that most people use. Yeah. There's other ones. I think Xcode has its own if you want to do something on the Mac.
Yeah.
And then there's other ones out there as well. But there's nothing you have to really do, right? Because it knows how to take your code and turn it into binary that the computer can run.
Right.
With an interpreter, the interpreter is the thing that's just doing the work, effectively. Yeah. It reads your stuff, and then it evaluates it, and interpreters are usually the part that's compiled. Right, so it knows how to run on that given machine.
I mean, are you saying that a compiler is just an interpreter that is run once rather than constantly?
To some extent. I mean, that's not...
It's kind of semantics?
That's a way overgeneralization of it.
Yeah.
To some extent.
But I mean...
But I know that they exist. I know that there are REPL-like things for C and C++.
Yeah.
But you wouldn't write, like, your entire code in there. A lot of that has to do with how those languages work behind the scenes. Because if you write a compiler, there's a whole thing about how you, like, interpret the syntax and, like, where those things go. And that's true in an interpreter as well. But the ways that the memory is managed is probably going to be very different between your compiler and your interpreter. With a compiler, you often will have the ability to, like, optimize your code, for example. And I've had programs that I've written fail when optimized and work when not optimized because I was pushing the bounds of like an array I was writing into.
Yeah. Well, I think you're getting at the point I was dancing around. Like, why would someone compile over interpret?
It's faster.
It's faster. Well, the resulting application is faster.
Correct.
Right, because it can do those kinds of optimizations in a stage and then give you optimized code, whereas the interpreter is running it as it's reading it basically, and so it can't be as performant.
Right. It's like if you watch a UN discussion, right?
As you do.
I try not to.
Very often.
But if someone's speaking a language that you speak, that is you're getting that right away. There's no interpretation.
Yeah.
Right. So if someone's speaking English for us, we don't need an interpreter to interpret the language, so we instantly understand what it's saying. But if someone's over there speaking Mandarin or something, they have literally, like, I made the joke about it at the top of the thing. I didn't realize I was going to bring it back to actually be useful.
Callback, nice.
Right? But, they have an interpreter who's then interpreting it. So you get a delay, right? Between the time that they said the word and the time it actually is executed in your brain, there's a delay because that interpreter had to hear it, process it, and respond.
Yeah.
As opposed to if they had taken their speech and run it through a translation process, which would basically be a compiler, and then had someone who could speak English read that out loud, you wouldn't need that, right? So it would be faster.
Oh, so here we go. So I love this analogy because now I'm thinking of, like, say a speech someone's giving. You could have let's say you were deaf and you have an ASL interpreter up there. Mm-hmm. You're getting a real-time interpretation of what's being spoken in whatever language to ASL, and if you're there and you're deaf and you're watching them, you're getting that delay, but you're getting it. Yeah. Or you could wait and somebody could have
they could do a
transcription, and later when the speech is done, you read it. Yep. That's sort of the compilation version versus the interpretation.
That's probably the best
I like that.
Layman's analogy for this.
That. Yeah.
I love that we joked about it at the top, and then it ended up becoming
There's
real.
No joking here. This is dead serious, man.
I think in analogies. I like the REPL.
Yeah.
Compiling has its uses for being fast and being optimized, and you can make it more secure. Like, right, you can bake things into your compilation. At a former company, I'm trying to figure out how much I can actually say here because it's proprietary. We had basically a wrapper around our main binary, so that our actual binary was was encrypted, and then the wrapper would basically decrypt it.
Okay.
Right? And so that was the thing that happened at the very beginning of the program, so there was a little bit of delay, but then it was in memory decrypted and it could run. And that was to keep people from looking at the source code and reverse compiling it.
Right.
They can still do that, but it's harder that way. And,
right. So another reason, as someone who primarily does web dev and primarily is always using interpreted, like, I think the only time I've ever actually really used compilation was when I was learning programming back in the late 90s, early aughts. Because I my first programming class was in C, and my college courses were all in Java. And so the idea of, like, I'm going to write source code, and then I'm going to compile that source code, and then I'm going to run machine code was normal. But then when I first was like, wait, no, I want to start writing web pages and, JavaScript and stuff like that, and Ruby and PHP and Perl and Python, like, all that was just like, there was no compilation. It was just interpreted.
Right, so you write the code and then you say run. Right. There's no step there.
Right. And I love that. I was like, why can't everything be like that? But one of the drawbacks of that is when you're trying to do debugging and when you're trying to write error-free code. A lot of people say compilation is better. Like, catching your bugs at compilation time is better than getting your errors on the website as it's running.
For sure.
And especially because a lot of interpreted languages tend to use, like, untyped variables, and so, like,
duck typing.
You think that this variable couldn't possibly be the wrong type, but somehow the wrong type gets in, and then you get some weird error message that you don't understand. Right. You would have noticed that if you were using a compiled language, because it would have said, you can't. This code is no good because it could be null, and you didn't check for that.
Yeah, runtime errors are always worse than compile time errors.
Yes.
So for interpreted languages in particular, we have things called linters.
Yeah.
I don't know why they're called linters, but they lint.
Because it's like your clothing has a bunch of hairs and you're, like, getting it off.
And what they do is effectively look for things that might be runtime errors.
Yeah.
It's kind of like compiling, except that the output is not something else.
It's not the code you're going to run.
It looks at your code, and that's easier with, like, if you look at linting a JavaScript program, you're not going to get as good of results as you are with TypeScript if you're actually typing your language, you're typing your variables, because it can identify problems.
Yeah.
And then with the whole, like, IntelliSense thing in your IDE, it sometimes will catch that as you're writing it.
Right.
Like, there's no field called flap. It's actually supposed to be fall. Oh.
Right. Right. Or like I remember the first time, I think when I was doing Objective-C or Swift, when I was trying to write iPhone programs, the whole idea of a variable or a property having a question mark at the end, because it might be null. It's like an optional thing. that's something that finally got its way into JavaScript.
Yep.
And
I actually really like that
yeah,
particular
I love it
aspect.
too. But it's one of those things where when you first start writing interpreted code, you want to write fast and you want to use dynamic typing, and you don't really think about whether something could be the wrong type or the you're just writing such good code, like you'll never have to worry about that.
Right. Well, because in a lot of ways you're just looking at trying to get something out the door, right? And
Right.
if you're writing something for yourself or for a really small, like something with low impact, right?
Yeah.
If it were to fail, I think a lot of times those are fine, right? I still do that for my prototypes, especially in Python, almost never have typing. I add typing after.
Yeah.
My TypeScript tends to start with typing because I almost
Well,
only
it forces you to use types, doesn't it?
you can
Or you
set
can
up
just do
your-
the any. Yeah.
But you can also just set up your TS config so that it says that you don't care.
But that's not default.
Right.
You have to specifically say,
Yeah.
don't save me.
Yeah.
Which kind of defeats the whole purpose of
But
TypeScript.
like when I'm writing TypeScript, I'm almost always writing it for work, and so for my professional side of my programming,
You're perfect every day.
I try to avoid runtime errors as much as humanly
Yes.
possible and make my code maintainable, and types help with that.
Yeah.
Right, but that's not an interpreted language thing necessarily. You could, I'm sure there are untyped
Compiled languages.
compiled language. I'm sure there are, but it seems weird. It makes way more sense that level of dynamic typing makes more sense in an interpreted language.
Yeah. I think it's also kind of funny that we started out with compiled with types, and then we went to, once again, generalizing, then we went to these interpreted languages with dynamic typing, duck typing, as you say, if
If it looks like an ant and
right, if
quacks
I set
like
it
an
to 10, it's probably an ant and not a
Yeah.
string, or,
Although I really like those when they can just interpret it as either one. Those are great.
Right. Well, obviously, yeah, languages get smarter and can handle more things and don't just, die because they got a value they didn't understand.
Exactly.
Like they try, yeah. But we've also, going from JavaScript to TypeScript, we're almost like coming back to the wait, that thing we lost when we went to interpreted with the typing, that's actually really useful. Maybe we should add that back into and get the best of both worlds. And I feel like unless you're doing like games programming or something where performance is really, really important, like everything I'm writing is in interpreted languages now.
Same.
Like I don't even know why I would use a compiled language now.
Yeah. I think games is a really good example. I think there's other,
Or something for a phone has to be compiled.
I was going to say,
or an iPad.
I was going to say anything embedded, right? Like my
Yeah.
router undoubtedly was compiled, right?
Yeah.
But I think it's the same deal as what I saw, 20 years ago, which is I would write, C++, and I would compiling that. But every once in a while I'd have a section that needed to be really, really efficient. Mm-hmm. And we would actually write assembly in our C code, and so so we're basically telling the compiler, I'm optimizing this. I'm telling you how to do this part, right?
Yeah.
Just make this part runnable.
Yeah.
Yeah. What was your first experience with interactive, with interpreted language? What was the language?
I mean, it probably JavaScript. I mean, because but I mean, like on a larger scale, probably Ruby.
I would have thought PHP.
Sorry, you're right. It was PHP. Yes, the first real web program I ever did that had like a database and users and content that like a CRUD kind of thing. PHP.
Because PHP and Perl were kind of like, I don't want to say in competition, but mine was Perl in a lot of ways. Like I did a ton of stuff in Perl.
You're a little more graybeard than me, just a little.
Right. Well, I think I'm like 1 year ahead of you school-wise.
Yeah.
So I was left over with what I had.
Yeah.
Right. So something like PHP didn't exist when I was learning Perl.
Yeah.
So I think Perl probably was mine, but around that same time I was also learning Lisp in one of my
you can't say it without.
It's really hard to not.
I think that's on.
And recognize anything I say when I'm talking about Lisp is wrapped in many parentheses. Lisp is the first place where I remember actually really digging the REPL and really enjoying I wrote this code and it goes right.
Yeah.
I used Emacs a ton back then because I liked Lisp so much, and all the configuration for that was in Lisp. It was Emacs Lisp, which was a variant of Lisp.
Yeah.
But like I wrote it and then it was there, and I didn't need to like reload Emacs. Next time I opened a new document, it used that new config, right? And that kind of stuff was really cool. Whereas if I did VI, typically I would have to exit out, come back in, blah blah blah.
I agree with all that, and I had something to go off of from that, and then it just into the ether. Wow. Oh, I was gonna say, isn't one of the reasons why interpreted languages have become more popular also just because computers have gotten faster?
Yes.
And they can handle the interpretation?
Yep.
Okay. And before they couldn't.
Right. I mean, I think there's a reason that we started with, punch cards, but
yeah,
getting to, modern times at all, things I learned about in school at least. You start with assembly because the computer.
How was ENIAC, Matt?
He's a fun guy.
Okay.
But like I took an assembly class in college. I thought at the time, why am I taking this? They have compilers. But then I just mentioned the example of where I had to use it in real life.
Yeah.
But like you write an assembly because you didn't have anything smarter to do the last piece of to do that last piece. It wasn't going to get smart enough to optimize your code or figure out what print meant, right? And I didn't really understand how that worked until I took that compiler construction class.
Yeah.
Because in the compiler construction class, our compiler wrote assembly as the back end, and then it assembled it. So we wrote a very specific. We wrote a very specific type of assembly because we were like, okay, this is the machine we're going to be writing this compiler for.
Yeah.
So we had to learn that assembly language, and they're all more or less the same.
But just different enough.
Just different enough to be really annoying.
Yeah.
But like that was probably the first time I ever actually used assembly outside of my assembly class was in there. So we had this lexical analyzer, Lex, that would parse your language, and then we used Yak, which was yet another compiler, to take that and help us turn that into the assembly, right? And there was a lot more on top of that.
Yeah.
But we used those tools. And I think that's kind of fun. But ultimately, I don't want to do any of that stuff.
Yeah.
I just want to write code because it's fun.
Yeah.
And as the machines have gotten faster, I don't have to. It's okay to wait a millisecond for an interpretation.
Yeah.
Right? If it takes 5 minutes to run your interpreted language, maybe that's a problem.
Yeah. Well, does that mean that if I had been doing my advent of code in C or Rust, my horrible brute forces might have actually worked if I used them?
I think it's more likely that they would have run faster. That's the answer I'll give.
Excellent answer.
But also, like, there's levels of optimization in the C compiler, I know for sure.
Sure.
And some of those might get smart enough to actually, like, smooth out what you did. Which is basically just at that point using a library.
Yeah.
Right. But compiled languages is why I used to get questions and interviews like, what happens in C if you have int a equals 5 and int b equals 6 and you type a plus 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 b? What is that going to do? Because compilers are going to interpret that sentence different, or that
statement?
Statement, yeah. That the syntax of that statement differently. It might say a plus plus, which means increment a now, or use a and then increment it, plus b, or it might say a plus plus b, which would be pre-increment b, and then add them together, right? And so the answer is, it depends on the compiler.
Right.
What that actually is you wrote bad code.
Yes.
Never do that.
Don't do that.
Right. Which is the answer I gave in the interview where someone did actually ask me about that. I said, it's up to the compiler, but if you did that, I would have a lot to say on the review of your code.
Yeah. Please don't do that.
Yeah. What is your favorite interpreted language to use?
It's got to be Ruby. Every year at Advent of Code, I keep going back to it.
Python's mine.
Yeah.
And I really like Ruby as well. Like honestly,
always Python.
The only reason that
is it because you used Python first? Because I used Ruby first.
No, I think I actually used Ruby first.
Oh, really?
But Ruby never had the community behind it that Python did. Python.
You must have used Ruby after its heyday. No, because
I used it well before its heyday.
There, yes. Well, you didn't use it during its heyday. Before or after, yeah.
And like, because I didn't like Python as much, and in Ruby, I love that everything's an object. Yeah. And that still upsets me that it didn't take off just because of that.
And I'm still a little iffy about the not the way that a function starts and ends with the indentation is the most important thing, and the
for
colon.
Python, yeah.
It's fine, but like Ruby is closer to C and JavaScript, which feels homier to me. So that's
I was definitely one of those people that poo-pooed the whole spacing thing with Python.
Okay, yeah.
But then I was just like, well, the code is pretty. I can read it, and I've never had a problem where I didn't indent something at the wrong thing and got surprised by it.
Yeah.
That has never been a problem in like 25 years.
Yeah.
So, but Python's fine, but Ruby's so close. But what is not is Perl. I hated Perl. Perl's awful.
I tried to use Perl for an Advent of Code year, and I got through about several hours of just trying to set it up so it would work right, and I gave up.
Perl is one of the reasons I never did PHP. It's because they looked too similar, and I got flashbacks.
But PHP is, especially now, man, they've done so much to PHP. Like, it's one of those languages that, like, never gets respect, and yet powers, like, half the internet, and has been around forever, and has only gotten better. But because it got super popular at one point, and everybody was using it, and there was a ton of bad code out there, it gets a bad rap, and it's so hard to come back from that. If you're not writing stuff in Rust or whatever the latest JavaScript framework is, like, it's kind of poo-pooed.
Yep.
That's just how the internet is. Anyway,
that's our interpretation of this difference between interpreters and compilers.
And once I edit this down to a final MP3 file, that will be the compiled version of this discussion. So you get the whole enchilada. You're welcome.
Whole kit and caboodle.
Yes. So thank you for listening to this episode about compilers versus interpreters. Hopefully it was illuminating. If you want to listen to more of our discussions, you can go to hackingthegrepson.com, where we try to put out an episode every other week on Wednesday. Until the next time we compile your interpreted thoughts, we now return you to your regularly scheduled lives already in progress.
Bye.